Good morning everyone, welcome back to Z Physics. Today we're going to be solving a quick question on circular motion. Okay, well, let's get into it. First off, explain why for an object traveling in a circular path, the speed of an object remains constant despite the fact there's always a resultant force acting on the body. Well, when an object is moving in a circle, there will always be a force acting towards the center of rotation. The velocity will be perpendicular to that and there will be no work done. So we can say that the resultant force, or the centripetal force, is perpendicular to the direction of motion. And hence, there is no work done. Okay, for the next one we have this fairground ride which causes people to rotate in a horizontal circle of radius 2 meters as shown in the figure. We have a person of mass 60 kg, completes one revolution every 3.6 seconds. Calculate his speed. Okay, well, if we know the time period, because one revolution every 3.6 seconds, that's actually a time period, his speed is just omega multiplied by r. So omega is our angular speed, which is 2 pi divided by t multiplied by the radius, which is going to be 2 pi over 3.6 times 2.0, which is going to give us 3.5 meters per second. To calculate the resultant force, all we need to do is just use mv squared divided by r. The most common error, remember, is to forget to square the r, so we're just going to be quite careful. His mass was 60 kg multiplied by 3.5, our answer from above, which we're going to square. We're going to divide that by the radius, which is 2 meters, yeah, so 2.0 meters, and we're going to find the resultant force of about 368 newtons. Let's use two significant figures, so 370 newtons. This next one is really interesting. So we have a person which is on this ride, and what we need to look is the way or which way the resultant force is actually acting. So complete the diagram to show the resultant force. Well, the resultant force will always be towards the center of rotation, which will be along here. If you think about it, another way of thinking about it is that the force which the ride exerts on the person is going to have two components. It's going to have a vertical component that's going to just cancel out the gravity, and we'll also have a horizontal component which will be providing the centripetal force. So the resultant force will actually be a little bit smaller, but it will just be along here. So this here is our resultant force. Finally, to calculate the force which the ride exerts onto the person, this here is just our hypotenuse, which is just this side. There's a couple of different ways of doing that. We can use this side here, or we can use this side here. We know that this angle here is 30. We're looking for F. We know that the upwards component, if the person is not moving up or down, will have to be equal to mg. So we can just say that cosine of 30, because this angle here is 90 degrees, cosine of 30 will be equal to our adjacent, which is mg, divided by our hypotenuse, which is f. So this means that f will be equal to mg over cosine of 30, which will be 60 times 9.81 divided by cosine of 30, which is about 680 newtons. Okay folks, well, hopefully this makes sense. If there are any questions, do let me know.